Alright, in this video, we're going to discuss Chapter 2, Section 1. Well, we're going to review it. We're going to review Piecewise Defined Functions. Then we're going to look at Section 2. The Algebra of Functions and the Difference Quotient. So let's review piecewise defined functions first. First, graph this function, g of x plus 4 when x is less than or equal to 2. 3 minus x when x is greater than 2. Yeah, so these are your y values. These are your x values, your domain, your range. Let's graph this one. 2, 3, 4, 5, 6. This is my x. And vertical is my y axis. So we have two separate equations here. We have g of x equals x plus 4 for all the x's less than or equal to 2. And then we have another function, 3 minus x, for any x greater than 2. So we'll draw both of those graphs, x and y. We notice it's a linear equation, so we only really need 2 points. So we start off with 2. X is less than 2, so it's saying we have to go to numbers to the left of it. So less than 2 is 1 and 0. If x is 2, 2 plus 4 is 6. If x is 1, 1 plus 4 is 5. If x is 0, 0 plus 4 is 4. So at 2, 2, 3, 4, 5, 6, I have, because it's equal, I have a solid dot there. At 1, 1, 2, 3, 4, 1, 2, 3, 4, 5, have another dot. And at 0, 1, 2, 3, 4. So it's a straight line. It goes that way forever. That's his first graph. Now let's look at the second one. Same thing, make an x and y. This one says x is greater than 2, so I start off at 2, then I go to 3 and 4. 3 minus 2 is 1. 3 minus 3 is 0. X is 4. 3 minus 4, negative 1. But remember, we can't use 2, so we have to have an open circle here. So at 2, 1, we have an open circle. At 3, 0, we have a dot. And at 4, negative 1, we have a dot. So the graph here goes right there forever. And if I asked you g of 1 or g of 5, what are those values? Well, here, this is your x value. X is 1. Which one of these two domains does it fit? Is 1 less than 2 or is 1 greater than 2? Less than. So I use this formula. 1 plus 4 equals 5. Now 5. There's my x. Is 5 greater than 2? Yes. So I use this equation. 3 minus 5 is negative 2. Remember, these are also points. This is the x, this is the y value. That's the x, this is the y value. So we can plot those points as well. Alright. F of x equals negative 5 over 6x plus 1 when x is less than 6, or it's negative 4 when x is greater than or equal to 6. So at the number 6 here, it'll be an open circle. At the 6 here, it's going to be a closed circle. But we have to use the endpoints. Let's look at this graph. 3, 4, 5. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. This is x, this is y. So f of x equals negative 5 over 6x plus 1 when x is less than 6. Again, it's a straight line, linear equation, so all I need is 2 points. So the first x I pick is the endpoint, 6. If I put 6 inside there for x, the 6's cancel. We have negative 5 over 6 times 6. So those cancel. Negative 5 plus 1 is negative 4. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4. It's an open circle at negative 4. 2, 4, 6. Oops. Now, since that's a 6 on the bottom, let's use all the multiples of 6. Less than 6. So the next easy number to use is 0. 0 times anything is 0, so equals 1. At 0, it's 1. So we have that part of the graph. Now the second half of the graph equals negative 4 when x is greater than or equal to 6. So again, I start off at 6, but this time I can use it. When x is 6, y is negative 4. Put a solid dot there. When x is 7, y is negative 4. And so on and so forth. So those are those values. F of x equals negative 2x minus 12 when x is less than negative 4. 1 between negative 4 and 1, x plus 7 when x is greater than or equal to 1. Now, graph and find these values. F of negative 6, f of negative 1, f of 1, and then f of 2. So let's look at the graph. We have 3 distinct parts to it. 6, 7, 8. There's my y values. 3, 4, 5, 6, 7, 8. So these are my x values. And then likewise negative. Then going down. So the first function is f of x equals negative 2x minus 12 when x is less than negative 4. It's a linear equation, no exponents or anything. So when x is negative 4, negative 4 times negative 2 is 8. 8 minus 12 is negative 4. Has to be going left. So f negative 4 go to negative 5. Or negative 6, it doesn't matter, just pick one. Negative 5. Negative 5 times negative 2 is a positive 10. 10 minus 12 is negative 2. Then negative 6. Negative 6 times negative 2 is positive 12. 12 minus 12 is 0. So at negative 4, it's negative 4. It's an open circle since there's no line. Negative 5, negative 2. And then 6, 0. So my line here looks something like this. Then my second line, f of x equals 1 from negative 4 to 1. So at negative 4, negative 1, 0, 1. At negative 4, it's 1. At negative 1, it's 1. At 0, it's 1. Because if there's no x values, nothing changes there. So at negative 4, it's 1. It's a solid dot because it's an equal sign. At negative 1, it's 1. At 0, it's 1. At 1, it's an open circle because there's no equality there. And the third one, f of x equals x plus 7 when x is greater than or equal to 1. So 1, 2, 3. 1 plus 7 is 8, 2 plus 7 is 9, 3 plus 7 is 10. And it's included. So at 1, it's 8, solid dot. 2, it's 9. 3, it's 10. So the graph goes on like that. Remember, when you're looking at these things, these are your y values, these are your x values. So if I'm using these x values, I got to use this function. If I'm using these x values, I got to use that function. And these to there. Alright, so that's a review of piecewise defined functions. Now, Chapter 2, Section 2, the Algebra of Functions. The Algebra of Functions. Let's pretend we have two functions, f of x and g of x. They can be whatever. When we talk about the algebra of functions, all we're saying is that these two functions can be added together. They can be subtracted. They can be multiplied. and they can be divided as long as your denominator does not equal 0. So that's the algebra of functions. That's one way of doing it. Or we could do it this way. F minus g of x. F times g of x. And then f divided by g of x. What these tell us is that we can add the two functions together and then take the x value, or we can take the x values of each and combine them that way. And you're going to see that one way is always easier than the other. So, given these two functions, 2x plus 3 is f of x, and x minus 5 is g of x. I want you to find f plus g of 3. So, from above we have our formula. So we have f plus g of 3 is equal to the same thing as f of 3 plus g of 3. But this is your x value. So anywhere I see an x, I put that in there. Now let's look at the left side. We're going to work about both sides, and we're going to see that one side is much easier than the other. What this one says is I can combine both of these functions first. Here's f of x, and here's g of x. Okay, so first thing I do is combine like terms. 2 plus 1 is 3x. 3 minus 5 is negative 2. Now, anywhere I see an x, I put a 3 in there. 3 minus 2. 3 times 3 is 9. Minus 2 is 7. That's one way. Or we do it the other way. F of x is 2x plus 3. So I can just put 3 in place of x. Plus, there's the first equation. And the other one, x is 3, so it's 3 minus 5. Right. These are, it's easier if you put them in parentheses also. If you don't need it, you don't need it. But whenever we deal with subtractions, you will need it. 2 times 3 is 6 plus 3. 6 plus 3 is 9. 3 minus 5 is negative 2. 9 minus 2 is 7. So, there's the first one. Alright, so let's look at the homework problems. That's how they work. Yeah, obviously the right-hand side is much easier. So f of x equals x minus 2. G of x equals x squared minus x. Find f plus g of 4. F plus g of 4 is equal to f of 4 plus g of 4. So let's put these together in there. So it's x minus 2 plus x squared minus x. We don't need the parentheses, so we just go ahead and add the numbers. x minus 2 plus x squared minus x of 4. Combine like terms, the x cancels with the negative x. So we have x squared minus 2 anywhere you see an x, put a 4 in there. 4 squared is 16, minus 2 is 14. F, here's f, so anywhere you see an x, put a 4. So it's 4 minus 2 plus 4 squared minus 4. This is f, and that's g at 4. 4 minus 2 is 2. 4 squared is 16. 16 minus 4 is 12. 12 plus 2 is 14. Ta-da! That's the answer. So, all right, number 2. F of x equals x squared minus 6. G of x is 6 minus x. Find f minus g of negative 10. F minus g of negative 10 is f of negative 10 minus g of negative 10. So f is x squared minus 6 minus 6 minus x of negative 10. So there's your f, there's your g, and there's your minus. See, if we didn't put the parentheses around the second one, so anything after a minus sign, I always put parentheses around it. Because if I didn't put that there, that negative would only change that to a negative 6. But it's supposed to change both of them. So I don't need the first parenthesis. This one I have to distribute. So it's a negative 6 plus x. Because this is negative 1 times 6 is negative 6. Negative 1 times negative x is positive x. X squared plus x, negative 6, negative 6, they're both negative, so you add them, negative 12. Put negative 10 anywhere you see an x, so negative 10 squared plus negative 10 minus 12. Negative 10 squared is 100. Positive and negative is a negative 10. 100 minus 10 is 90. 90 minus 12 is 78. Now let's do the easier side. So the first one, we have at negative 10, we have negative 10 squared minus 6 minus, there's the minus, 6 minus negative 10. So whenever you put a negative value inside there, always make sure you put parentheses around them. So negative 10 squared is 100 minus 6. That's 6 plus 10. 100 minus 6 is 94. 6 plus 10 is 16. So 94 minus 16 is 78. Alright, so the next one. F of x equals x squared minus 3. G of x equals 3x plus 5. Find g minus f of 3. So I have g minus f of 3 is equal to g of 3 minus f of 3. Basically, all you're doing is distributing that x to both of those. So, the first one is 3x plus 5. There's the minus sign. And then we have x squared minus 3 of 3. Okay, the first one, I drop the parenthesis, 3x plus 5. I got to distribute that negative sign, so it's negative x squared. Negative and negative makes it positive 3. Combine like terms. I have a negative x squared plus 3x. 5 plus 3 is 8. Notice how I put it from the highest exponent to no exponent. This will be second nature to you as we go on. So now, anywhere you see an x, just plug a 3. So negative 3 squared plus 3 times 3 plus 8. Notice this negative sign is not in a parenthesis, so this is done first. So 3 squared makes it negative 9. 3 times 3 is 9 plus 8. So they're canceled. The answer is 8. Let's look at the other side. So 3 times 3 plus 5 minus this one, 3 squared minus 3. So 3 times 3 is 9 plus 5. 9 minus 3. 9 plus 5 is 14. Minus 9 minus 3 is 6. 14 minus 6 is 8. So notice how every time this side always finishes a lot faster. Alright. Number 4. H of x is equal to x plus 3. G of x is equal to the square root of x minus 9. I want you to find h minus g of 0. So actually, I mean, we could do h, but we also know that it's easier if we just do h of 0 minus g of 0. So when x is 0, we have 0 plus 3 minus square root of 0 minus 9. 0 plus 3 is 3. 0 minus 9 is negative 9. Can't be done, no solution, because this cannot be done. Error. Because if you remember from our chart earlier, the square root function, the graph of which looks like this. The smallest it could be is 0. It can never be negative. This is negative, so it doesn't exist. Because 0 is not the domain of our function. Let's look at the domain. Let's look at h of x, the domain of h of x, the domain of g of x, and the domain of h minus g of x. And we'll look at and find a shortcut. So, this is a linear equation. Linear equation, x can be negative, positive, or 0. So it's everything from negative infinity to positive infinity. How about this one? This one, we have to first set that equation to 0 and solve for x. So we add 9 to both sides. So x is equal to 9. So our graph here has to start at 9. And it goes to infinity. So the domain of your function is where these overlap. So the domain of your function is from 9 to infinity. So basically, it's the smallest of the sets where they overlap. Alright. So that looks at the domains also. H of x is x plus 1. G of x is square root of x minus 2. And talk about the domains. Remember, this is linear, so the domain is from negative infinity to positive infinity. So I can use any x's there. But this one starts at 2, goes to infinity. So my only x's I can use can either be 2 or higher. So the question is asking for g over h of 2. It works there. Since this one starts off at 2 and goes higher, and that's a 2, I know I'm going to have an answer. Alright, so what we have here is g of 2 over h of 2. That's 2 minus 2 over 2 plus 1. But there's h, put a 2 in there, put a 2 there. Square root of 0 over 3. Square root of 0 is 0. 0 over 3 is number 0. So that's your answer. So we can always do a precursor look at the functions and see if our domains can be satisfied. If either one of them do not exist, then the whole thing's not going to work. Find g plus h of 7. Yeah, this is linear, so it goes from negative infinity to positive infinity. 7's inside there, that'll work. This one, x minus 7 equals 0. Add 7 to both sides. So the domain of that one, check, it'll work. So no, this one's going to have an answer. So g of 7 plus h of 7, that's what that means. 7 minus 7 plus, there's that plus, 7 plus 1. There's g and there's h. 7 minus 7 is 0. 7 plus 1 is 8. 0 plus 8 is 8. Alright, so that's the algebra of functions. Now, let's discuss the difference quotient. Difference simply means take two numbers and subtract them. We use that all the time in our equations. Quotient means fraction. The difference quotient basically is looking for the slope, but not the slope that we used in the past of the straight line. This one we can use to find slopes of curves. So what we're going to do here is we're actually looking for the average rate of change. So in the past, we had y2 minus y1 over x2 minus x1. This works for lines. We had 2 points. This is x1, this is x2, this is y1, y2, the slope of a line. What we're trying to find out here, so we have a curve, and you have 2 points. Here's your x1 there, there's your x2 there. If we drew a straight line there, we're not finding the slope of the curve. This is called a secant line. Secant line is a line that crosses a graph at 2 points. There's point 1, there's point 2. But again, it doesn't tell us the slope of that curve, because anywhere along the curve, the slope changes. Linear equations only work for 2 points in one straight line. Okay, I'm going to continue this on another one because I have to clear up some memory. Alright, so I'll continue the difference quotient on the next video.